I'm going to solve my homework too. So let's start. We have here in the first question, we're asked to find the transfer function of the electrical circuit shown in figure 1. So here we have an RC circuit, so we're going to solve it. Okay, so let's start here by R1 C1 and we have here R2 C2. So we can call this R1 C1 S R equivalent 1 and R2 C2 S R equivalent 2. So here let's find R equivalent 1 and R equivalent 2. So R equivalent 1 is equal to R1 plus 1 over SG1, which is equal to R1 G1 S plus 1 over SG1, and R equivalent 2 is equal to R2 plus 1 over SC2. So here we can say is also equal to R2 C2S plus 1 over SC2. So here let's find, or let's redraw the circuit again, and we can redraw it like this. We can call this as E input and here as E output, and you can call this R equivalent 1 and you call this as R equivalent 2. And as you can see here, this is a voltage divider circuit. So according to voltage divider circuit, you can say that E output is, so E output is equal to E input time R equivalent to divided by R equivalent 1 plus R equivalent 2. So here, as we have already R equivalent 1 and R equivalent 2, we can replace them to the equation, and you can find here E output divided by E input is equal to R2C2S plus 1 divided by SC2 and R1 C1S plus 1 is also divided by SC1 plus again R2 C2S plus 1 divided by SC2. So arranging this equation, you can find, so we are going to send this SC2 to the denominator and we can arrange them again. So let's see what will happen. R2C2S plus 1 divided by R1 C1 C2 C1 S squared plus SC2 divided by SC1 plus, so here as we have already SC2 here, so we can simplify them just, so we can have only R2C2 S plus 1. So arranging again this equation, you can find, So we are going to multiply this with this one and sending this to the numerator. So we will have here A output divided by A input is equal to R2 C1 C2 as we multiply it, S square plus S plus SC1 divided by RC1 C2 S square plus R2 C1 C2 S square also plus SC1 plus SC2. So here we can simplify S in both sides, and we can find here E output divided by E input is equal to R2 C1 C2 S plus C1 divided by, here we can take in parentheses, S C1 C2 multiplied by R1 plus R2 plus C1 plus C2. So this is our transfer function. Here we can say E output S and E input S. So this is the transfer function of the circuit. Okay, here we can continue with the second portion. So here we can take it close. So here we can say here second question. So here for first of all we can find the forward path gain, which is equal to 10 over S multiplied by S plus 5. So here let's continue, and you can say GS is equal to 10 over S plus S5 divided by 1 plus 10 over S plus 5 multiplied by 1 over S plus 1. So here running this equation you can find GS is equal to 10 over S multiplied by S5 plus 5 plus 10 over S plus 1. So arranging again this equation, we can find here 10 times S plus 1 divided by S times S square plus 6s plus 5 plus 10. And here we can say gs is equal to 10s plus 10 divided by s cubed plus 6s squared plus 5s plus 10. So we can find this gs space model as like this. If dx1 dx1 t dt dxt dt and dx3 t dt is equal to, as we know already, dx1t is equal to x2, and you can write it also here. dx1 dt is equal to x2, and dx2 dt is equal to x3, and dx3 dt is equal to minus 10 minus 5 and minus 6. So we can write here the space model. We have here in x1 0 is x1, and we have 1 in x2, and we have 0 in x3. Here we have also 0 in x1 and 0 in x2, but we have here 1 in x2. And here we have minus 10, minus 5, and minus 6. x1, x2, and x3t plus, so for ut we have only 110, which is in x3 we have 1 ut. So for this one we can say yt is equal to the numerator part of the power transfer function. So here in our case we have only 10s plus 10 and 0, so we can say yt is equal to 10, 10 and 0 xt. So here we can continue with the third question here. Here we ask you to simplify the block diagram step by step with block diagram reduction method. So we can redraw it here at x. So first of all, we can just move this node to this side. So by doing it, we should multiply h3 with g3 because we took it from here. So we should multiply it with g3. So let's redraw it here. We have here g1 minus, and again we have also another. So this is G2, and here we have G3, and here we have Y. So instead of here, we are going to take it from here. So as we take it from here, we should multiply H3 with G3, and as we have already here H2 to here, and we have H1 to here. So here we can say that no, here we have we should modify this. This is not here. This should be here, and this one is not here, but here. Yes, before 0. So we can modify it here. So H2 is here to this one, and H1 is here. Here we have X. So here we can see that we have a closed loop transfer function here. So we can calculate this here. We have forward path gain G2 divided by 1 plus forward path gain multiplied by feedback path gain G2 H3 G3. So we can redraw again this here. We can find here. We can find it like G2 divided by 1 plus G2 G3 H3. Here we have again G3, and we have Y, and from here we have H2, and again from here we have H1. And here also we can see that we have another closed loop transfer function here. So this one, and we can calculate it like this. We have the forward path gain G2 G3 H3 divided by 1 plus forward path gain that 1 plus G2 G3 H2 multiplied by feedback gain, which is H2. So we can simplify this here by sending this denominator to the main denominator, and we can find here G2 is equal to 1 plus G2 G3 H3 plus S. We are going to simplify this, which this we will have to G2 H2 here. Okay, so we can redraw again our block diagram as we are simplifying it. Here we have G1, so we have simplified this already. So we have find G2 divided by 1 plus G2 G3 H3 plus G2 H3. Here we have also G3 again, and here we have Y. So this is our H1 going here plus minus. And here we can also that you can see that we have again a closed loop transfer function here, which is this one. So again, you can calculate it here. So we have the path again, it is G1 time this transfer function. You can find here as G1 G2 divided by 1 plus G2 G3 H3 plus G2 H2. The whole divided by 1 plus again the forward path again, which is G1 G2 divided by 1 plus G2 G3 H3 plus G2 H2 multiplied by feedback gain, which is H1. So you can hear what H1, and this is going to be like this. You can arrange it and taking this part to the denominator, and you can find here 1 plus G2 G3 H3 plus G2 H2, and as we are going to simplify this with this, we will only find here plus G1 G2 and H1. So let's continue again towards this here. So we can find here x is going to this part. So it's G1 G2 divided by 1 plus G2 G3 H3 plus G2 H2 plus G1 G2 and H1. And you continue, we have here G3, and here we have Y. So here as they are series, we can multiply on this with this one, and you can find here x is going to be G1 G2 and G3 divided by 1 plus G2 G3 H3 plus G2 H2 plus G1 G2 and H1. And this is the simplified uh, model of our block diagram. Okay, so let's finish one. Mm, So here we can, yes, we have only this. Yeah. and here we have y. So this is the final block diagram. The simplified block diagram is found like this. So this is the answer of our third question. So let's continue. Let's continue with the fourth question here. We are asked to draw the signal flow graph of this one. So here we can see that y1 is the output. Is the input here y1. We have y2, y3, and here we have y4 and y5. Okay, so here let's see. We can see that y2 is equal to y1. So here we have only one gain, and minus h1 y3. So here we have minus h1, so it's going to the front side. And we have also minus h3 y5, minus h3 y5. So from y5 to h3, and here we have as feedback h3. And let's say y3 is equal to g1 y2. Y2 is equal to g1 y2, only g1. And in y4 we have g4 y2. Here it's g4, and we have only again g2 y2. This is g2, and we have minus h2 y5. So this is h2. It's going to counter side minus h2 y5, and finally we have y5 is equal to g3 y4. g3 y4. So as y5 is our output, you can say here y5 y5 1. So this is our the, the first part of the fourth question, and let's see the part B. In the part B, we're asked to obtain y5 over y1, y5 over y1. So first of all, here we should find the forward path. Here we can say we have here we have m1. Let's say m1. Then we have y1, y2, y3, y4, and y5. So here as m1 gain, we can say we have g1, g1, g2, and g3. And you can say that we have another way again with this part, this bed. We can call it M2. It's gonna be Y1, Y2, Y4, and Y5. Y4 and Y5. And here again we have only G4 and G3. G4 and G3. So let's see if we have the loop. We have how many loop we can see. We have, we can call it L1, which is Y2, Y3, Y2, Y3, again Y2. And here we can do it like this. And here we have only a minus H minus G1, H1. And again we have also this loop Y4, Y5, Y4. So we can call it L2, Y4, Y5, Y4. And here we have also as again we have minus G3, H2, minus G3, H2. Here let's continue. We have also another game. It's from Y2 to Y5, Y4, Y5, and again to Y2. So we can call it L3, and it's going to Y from Y2 to Y3 to Y4 to Y5, and again going back to Y2. And here again we have minus G1, G2, G3 and H3, G3 and H3. So let's see if we don't if you have another uh, loop pad. So we can see here we have Y2, Y4, Y5, and again it's coming to Y2. So you can see that you have another loop. It is you can call it L4. So here L4. So L4 here is equal. It's going from Y2 and coming to Y4, Y5, and again going back to Y2. And here we can write more than S minus G3, G4, and H3. So let's see if we have no touching loop. We can write them here, no touching loop. And here we can see L1 and L2 are no touching loop. Here L1 and L2, we have Y2, Y3, Y2, and Y4, Y5, Y4. So they don't have common point. They don't. They are not sharing uh, common point. So we can say that L1 and L2 are not touching loop. And again, others we don't have others not touching loop, only the two. So we can say the product of not touching loop again is G1, G3, H1, H2. Okay, so let's find delta. So firstly, we can find delta 1 for M1. So we have 1 minus, okay, so let's see if there is another notation loop with M1, Y2, Y2. So we don't have notation loop with M1, so we can say 0. So delta 1 is equal to 1. Let's see delta 2 is equal to 1 minus Y1, Y2, Y4, Y5, Y2, there we have, there is Y4, Y5. So there is no touching loop with delta 2, so it's 0. So delta 2 is also equal to 1. So now we can find delta. So here delta is equal to 1 minus. So here we are going to write the sum of the gain of all individual loops. So we have here minus G1 H1 minus G3 H2, and we have also minus G1 G2 G3 H3, and finally minus G3 G4 H3 plus no touching loop. So here we have only one no touching loop, so we can just write the product. So here we have G1 G3 H1 and H2. We have H1 and H2. So we can rewrite delta here. So delta is equal to 1 plus G1 H1 plus G3 H2 plus G1 G2 G3 H3 plus G3 G4 H3 plus G1 G3 H1 H2. And as we find our delta, we can find uh, the whole m. F y5 over y1 is equal to m is equal to sum of, here we have m1, we can see here m1, g1, g2 and g3. So this is all m1, m1 delta 1, so g1, g2, g3 time delta 1 is 1 plus m2 delta 2. So we can see here m2 is equal to g3 g4. Yes, g3 g4 multiplied by delta 2, it's also 1. So we can write here g3 g4 divided by delta. So we can write here delta. We have here 1 plus g1 h1 plus g3 h2 plus g1 g2 g3 h3 plus G3, G4, H3 plus G1, G3, H1, H2. And this is the answer of the part B from the equation 4. Yes, here we have problem. So thank you.